Hello, so welcome back to our online organic chemistry lecture series. And the topic for this video is how to give names for amines and other heterocyclic nitrogen bearing compounds. Now, amine compounds are considered to be derivatives of ammonia. In ammonia, you have a nitrogen that is bonded to three hydrogen atoms. For amines, they have a nitrogen atoms in which any of these hydrogens can be replaced by an alkyl group. So you can have here one alkyl group bonded to the nitrogen, and that can have two hydrogens bonded to the nitrogen. And these are primary amines. Now, we also have secondary amines and tertiary amines, which we will discuss in a while. For primary amines, they are named in the systematic IUPAC nomenclature by replacing the E of their corresponding parent alkane with the word amine. In common nomenclature, they are named as alkyl amines. For example, if we can have this molecule, the first thing we have to know is to find the parent, and the parent obviously must contain the most number of carbon atoms, and the parent has 4 carbon atoms in this case. Numbering is at the end nearest the amine or the carbon that bears the amino group. So in this case, the numbering starts on this carbon. So we could name this one as butylamine. In another example, so this is again a primary amine. This is named as cyclohexylamine because the nitrogen is bonded to a cyclohexyl group. All right, so how about for secondary and tertiary amines? Now we have to recognize how does a secondary amine differ from a tertiary amine. If we have here a nitrogen, and this nitrogen is bonded to two alkyl groups denoted by the letter R here, and of course you do not forget the hydrogen and the lone pair in the nitrogen, then this is a secondary amine. Now, if all the hydrogens in ammonia have been replaced by an R group, then we have what we call as a tertiary amines. Okay, so how do we give names for secondary, tertiary amines? One way of giving names for these molecules is to simply state the different groups bonded to the nitrogen and add the word amine. So for example, we have an ethyl group and we have here a butyl group. So the name of this molecule will be butyl ethyl amine. Again, we have to alphabetize the substituents before the word amine. Okay, so this one is quite simple because we have the same types of alkyl groups bonded to your nitrogen. Since they are the same types of substituents, then we use the prefix di. So the name for this one is the diethylamine. So if we have tertiary amines, we still follow the same naming of these molecules in such a way that we just simply state the substituents bonded to the nitrogen. So if we have similar types of substituents bonded to the nitrogen, we can use the prefixes. Notice that for this molecule, you have the same types of substituents. That is an ethyl substituent, so there's 3 of them, so we use the prefix tri. So the name of the molecule is triethylamine. And lastly, let us consider this molecule. So we have here a ethyl group, a methyl group, and a butyl group. So the final name is butyl ethyl methylamine. So this is one way on how we can give names for amines. All right, so another way of naming secondary and tertiary amines in systematic nomenclature is that the smaller groups in the amine nitrogen can be designated as substituents, and they can be given the locant N. Now, for this systematic nomenclature, we have to first find the parent, and the parent should have the most number of carbon atoms and contains the nitrogen. So let's take a look at this example. So we can actually use the earlier rules that we've discussed, and this molecule can be named as ethyl-methylamine. Again, we can just simply state the substituents bonded to the nitrogen and arrange these substituents in alphabetical order. But we can also use the systematic nomenclature in such a way that the smaller group bonded to the nitrogen becomes the substituent and they are given by the locant N. And the other group, which has the most number of carbon atoms, will become the parent. So in this case, the parent has two carbon atoms, and that is ethane. And we should drop the E and replace this one with amine. So the parent becomes ethanamine. Now, the smaller substituent will be given by the locant N. So in the final name, this is written as N-methyl ethanamine. Let's take a look at this other example here. So we have here a nitrogen, and we notice that we have two the same substituents, which is an ethyl group. So in the previous way of naming this, we could name this one as diethylamine. Now, in systematic nomenclature, we know that the parent has two carbon atoms, so that one is your ethanamine. And the other group is an ethyl group, so that will become N-ethyl ethanamine. Okay, so how about if we replace all the hydrogens in the nitrogen with an alkyl group? So we have here this molecule in which you have your ethyl groups bonded to your nitrogen, and there are three ethyl groups bonded to your nitrogen. So in this case, this can be named as triethylamine. In systematic nomenclature, this can be named as N,N-diethyl ethanamine. Lastly, we'll try to consider this example. So we have a nitrogen that is bonded to three different substituents. So we have here an ethyl group, a methyl group, and a propyl group. One way to name this one is to simply state the substituents bonded to the nitrogen and add the word amine. Now, do not forget to alphabetize those substituents. The naming of this molecule will be ethyl, methyl, propyl, amine. Okay, so in systematic nomenclature, however, the first thing we have to do is to find the parent, and the parent should contain the most number of carbon atoms, and this parent should also contain the nitrogen. In this case, this is the parent. So we have here carbon number 1, we have here carbon number 2, and we have here your carbon number 3. So the parent is this part of the molecule, and this is named as 1-propanamine. Now, the smaller groups bonded to the nitrogen are given by the locant N. We have a ethyl group, so that becomes N-ethyl, and we have here your methyl group, so that becomes N-methyl. So the final name for this molecule is N-ethyl N-methyl 1-propanamine. Just a piece of advice, whenever you write the substituents, then they should be written in alphabetical order. The other type of amines are called aryl amines. So these are amines that are bonded to the benzene ring. So for example, so you have here an amino group bonded to your benzene ring. So this is known as benzanamine or aminobenzene, and the common name for this molecule is aniline. So for this second example, that this is a secondary amine. Okay, secondary amine because we have two groups that are bonded to the nitrogen atom. So in this case, we can name this one as N-methyl aniline. Now for this type of molecule, we have an amino group and a methyl group. So between an amino group and a methyl group, the priority is the amino group. And this gives the new base name for the benzene. So you would recognize that this one is actually your benzanamine. So you would also recognize that the methyl group is in the fourth position with respect to this carbon. So we can have a para substitution. Now, the name for this one can be written as 4-methyl benzanamine. Or the common name for this is para-toluidine. All right, so if we move on to the last example here, we recognize an amino group bonded to your benzene ring, and that gives this molecule a new base name, just like what we did here, and the base name is benzanamine. Now, in this case, you also have this group, and this group is called your methoxy. Naming this molecule in IUPAC systematic nomenclature is 4-methoxybenzanamine. Now, the common name for this one, the non-IUPAC name or the trivial name for this one is called para-anisidine. The last type of nitrogen compound that I will discuss are what we call as heterocyclic amines. So when you say heterocyclic compounds, these are compounds in cyclic structures, and they contain an atom aside from carbon. So this atom can be an oxygen, this atom can be a nitrogen, this atom can be a phosphorus for that matter, or a sulfur, and these are all classified as heterocyclic compounds. If you have here X as nitrogen, then that is called heterocyclic amine. Now, in IUPAC nomenclature, we use the prefixes aza or diaza if you have here 2 nitrogen atoms, or triaza if you have 3 nitrogen atoms. All right, for heterocyclic amines, the nitrogen atom is assigned the position number 1, and the ring is then numbered in such a way that you give the lowest overall set of locants. So for example, in this case, you have your 5-membered ring, and we have here a nitrogen. So the name for this molecule will be 1-aza-cyclopenta-2,4-diene. So in this case, we have here the 2,4-diene to signify that the cyclic structure also contains 2 double bonds. We can use a similar way of naming this molecule for this one. So in this case, the nitrogen atom is the atom number 1, and we have to number the ring in such a way that the other atoms or substituents will still have the lowest possible set of locants. Remember that we have 2 nitrogens here, so we use the prefix diaza. And the final name for this one will become 1,2-diaza-cyclopenta-2,4-diene. Okay, so why do we have 2,4 here? 2 because the double bond starts at nitrogen number 2 and at carbon number 4. So in this next example, we have here carbon at number 3 being replaced with a nitrogen. So the name for this molecule will be 1,3-diaza-cyclo-2,4-diene. Again, the numbering starts at the nitrogen, and numbering the ring must still have the lowest set of possible locants. So we have here nitrogen 1, then carbon 2, nitrogen 3, carbon 4, and carbon 5. So this molecule is called your imidazole. And lastly, we have this molecule, and this one is named as 1-aza-indene. This is also commonly known as indole. All right, so we still have some few more examples of heterocyclic amines here. Okay, so notice in this example, this one looks like the structure of benzene. Again, if you remember benzene, okay, this is a cyclic structure with alternating double and single bonds, and all the carbon atoms are the same, and that is your benzene ring. So if we replace one of the carbon atoms with a nitrogen, then we use the prefix aza. So this molecule is named as azabenzene. Now the common name for this one is pyridine. This one looks like your benzene ring, and we have 2 nitrogen atoms, and we know that if you have the presence of the nitrogens, then we use the prefix aza. Now, since there are 2 nitrogen atoms here, then we use also the prefix di. So the final name for this molecule is 1,2-diazabenzene. All right, so using the same way of naming these 2 compounds, let's take a look at this third example here. So we have here a compound containing two nitrogens. However, this one is different from this molecule because one of the nitrogens is in the third position relative to this one. So the name for this one will be 1,3-diazobenzene. So hypothetically, if you have here a nitrogen in a carbon 4, then that will become 1,4-diazobenzene. Now, the common name for this molecule is pyrimidine. Okay, to conclude our examples for heterocyclic amines, let's try to consider this molecule. So this is named as 1-aza-naphthalene. So you would recognize the word naphthalene. So how does a naphthalene looks like? Naphthalene looks like fused benzene rings. So we can have here two benzene rings that are fused together, and that is actually called your naphthalene. So if you replace one of the nitrogen atoms with a nitrogen, then that becomes 1-aza-naphthalene. This molecule is also commonly referred to as quinoline, and that's how we give names for heterocyclic amines.